Hi everyone, welcome back to your channel. This is the third episode of the IoT Security, and in this session I would like to deep dive into coding part and to explain that what is the meaning of each line of the code. So if you're interested in this topic, please stay with me until end, and that could have started. So we have the first part of that. We have the libraries. So this part for the Wi-Fi, ESP32 need to connect with the internet, so we are using the Wi-Fi. That is very, it's crystal clear. We have the HTTP client, which we would need to push the one endpoint, the URL to the third-party system, which is here is a Keycloak. So in that case, also we would need this part as well. And this is for converting the JSON format in Arduino. This is very interesting part of that. Why we have such this kind of the library? Because basically you can use the one of them if you are connecting with the Wi-Fi, but we want to use another function of the ESP32, which is the saving mode of that. So we want to turn it off because our we can say the token is a little bit long, and we would need to wait a little bit more. So that's why we have to turn off this, we can say the capability or the saving mode of that, which is not available into the first library. Here we have to define the buffer. So why is this value? By default, the value of that for MQTT is a little bit short, or we can say it's small. So we have to reach to 1000 character for this token. So in that regard, we have to keep it in 2048 byte. That is our goal. That's necessary. And we have for library for MQTT, and also have library for sensor. So this is the temperature and humidity sensor. It could be other sensor as well, which is not very actually important. Then you would need to define your username, password, and also the IP address, which could be your laptop IP address if you are using your laptop, or might be the cloud IP address which you are targeting to push the data over there. I do understand such this kind of the method, which is not proper method, and probably you could use another style to save it in one specific file and then just refer it here. I think I already explained in other video. I will tag that video here as well to explain it how it will work. If you're considering the security, maybe that solution is much better than just simply write the username and password into the memory of your ESP32. This is the rel which you would need to define it. If you don't know how to do that, please watch the second episode of this series. I explained that how you can create a rel, and also the client ID and secret. Same. Similarly, you can find all this information into this video, which is the second video of this series. And here we have the last token refresh, which is because somehow we want to get the time stamp of that, and then to understand how long will take. And why is this way? Because we already defined the 60-second, which is the 1 minute interval for each, we can say the token refreshing. So basically, the idea behind of this kind of the authentication is this: if you first time you authenticate the ESP32 and then connect with the master station, or your cloud. Then it might happen you revoke your ESP32 or hardware or whatever. It happened. And then because you are not authenticating in interval and it's keep aliving, then the system doesn't know about it, whether such this kind of the situation happened, the ESP32 already gone or no. So it is somehow is the sample of hacking. That's why it need to always in some interval to authenticate whether it exists or no. If not, then definitely need to do the necessary step and also appropriate action, which I have defined in down part of the Discord. So this is actually the idea behind of that. Then we do have the definition for the pin part of connecting with the sensor, and also the type of that, which already is defined here. Again, it could be other sensor. It's not mandatory to be this sensor DHT or whatever for the temperature. It could be other sensor. Then we have for defining the MQTT, and also for JSON Web Token. So JSON Web Token, this is the token which is coming from the we can say the Keycloak, and then we have to define it here as some empty value. Then we have the get authentication token. That we can say that parameter or argument here is one value which connect you can define it how you can get this data from the Keycloak. So you have the URL, you have the method of the HTTP, and what is inside of this the HTTP the URL. You can find all this information into Keycloak, but you can also use this in case you want to use for your test, but just you should make sure your port exactly the same as my port, which is the default port of the Keycloak. And if you are changing this port, then it might change, but this port already it's fixed. Somehow you can find all this information. Then in the URL also you need to define the header part of that, and also what kind of because the parameters you would define in the body of that is username, password, secret, all these cases which already in top side has been defined. Yeah, so it's not a very problem. Then you have the method of that, which is defined what method you need to push, and we are dropping the value of the token into a temporary buffer. And why is this way? Because in case your internet or connection is dropped, if you are using this JWT token, then you will lose that. So that's connection failure. It might happen. That's why we are dropping into one temporary buffer, which help us to not losing that token at least for during this communication. Then here we have defined that if is the code is 200, which is stand for success response, then it will define it, deserialize the response, and everything is fine. It's the generate the token. So if not, then the authentication will fail. Here is the setting of the this the port, baud rate, and all these cases for the serial, which is the baud rate, and is the starting for using that specific sensor, which is here the temperature and humidity, and also the Wi-Fi for the username, password, and also that if the status is connected, then keep some delay for dropping into serial, giving you that okay, now already is connected. And this is exactly what in earlier I was talking about, that to turn off the ESP automatic, we can say that the sleep mode, and the network connection stay awake, because we have the very, not very, but actually we have the long, we can say the character for the token, and we would need to keep this alive. That is the reason we need this to make it offline. Then again, for the get authentication token, which earlier we already defined, drop it into JWT token, because this JWT token also is needed for, I mean, we will discuss it later, it's also needed for connecting to the MQTT and all these cases. And here we have the last token refresh, which is somehow initialize the timer for us, and this is required later. Also we will reach that point because we want to send in a different interval, and that that's the last token refresh is necessary because we want to calculate it based on that value, and if is more than that value, which is the 60, for example, second, then it need to be refreshed, and if not refreshed, then it should drop. That is the point. So if JWT token is empty, so it goes as a failed, and it need to be checking Keycloak and goes to we can say the infinite loop. Here there is a definition of the port size of the buffer, this how long MQTTs need to be alive, and this is the socket for the timeout is a 50 seconds. So this part is a little bit longer than this because it might happen in the first try it will fail, so we would need the second try to reconnect, or the third try. That's why we keep it for the 90 to be in the safe side and make sure that everything is working fine. And this part of the reconnect, exactly what I mentioned, it might happen the first connection, not everything not went well, is not going well. So in that case, you have to reconnect. So if there is a reconnect, then the serial writing that okay, this is a reconnect, and you have very we can say that nice part of this code as well. Why you need this? Because let me first tell you that what it's doing. It's every time give the one random number to ESP2 as a client. Suppose that ESP32, I don't know, 1. Then the second one in reconnect, it gives you 1122, something like that. Advise doing that because MQTT broker have a strict rule, and then it not accepting the two connected devices. So if you already ESP1, ESP32 then we'll think okay, this is already is connected, so you cannot try it again. That's why it gives the random number on the top of that to try for the second time. This is the idea behind of this. And then here for all this information, JWT token, which is required. So 3 actually parameters like a username, we can say the password, and also the client's ID. So here there is no basic authentication since we are connecting with the Keycloak, so that token is part of the password, that the client ID somehow is the username of that MQTT. So MQTT using that token base, not using like a one fixed basic authentication. So it is connected, then it will be connect. If it's filled, this goes to the fill, and there is some delay for just programming part. Then here in this loop, we are talking about authentication. We are saying that, okay, if this client is connected or reconnected, then, and if the millisecond minus the last token refresh, which before we already discussed, we drop the value on that to calculate, and every time it's starting after the first run of the token, it will start and initiate the timing, and then if reached to the threshold, which is here is a 60 second, then it need to refresh token. So if here get the authentication token, and if test token, which is here, is empty, then the security alert will rise up. Okay, something here is not correct, and then immediately it will disconnect the MQTT, not allow that to connect, and it goes to one true loop or infinite loop until they come and refresh the ESP32 again to renew that we can say the ESP32. And why is happening? Once you are turning off the we can say the client, or disable the client, then it will goes to this method or to this process, which is not authenticating this ESP32. So if you want to see that how is it in for the demo, please watch the first episode of this series. I already shown you as a demonstration how it will work. Over there I am turning off the client, and you will see that immediately it will disconnect the MQTT and not communicating. And once you are enabling, then you need to refresh the ESP32, which goes to normal, we can say, state. So else everything is fine, identity confirm, and well, continue until the next threshold reach. So here, once everything is confirmed, authenticated, all these cases and the data, so here we are creating one variable, this is 0, and then we calculate the 10 we can say the second for interval, and every time it's sending the data into this interval. So you can customize it, this interval, based on your we can say idea. So here they will check it, okay, how much time is passed, and if everything is correct, then they will reset the stopwatch or the last MSG. Here we have some data as a temperature, humidity. It will push to the MQTT, and these are the format of the data. Okay, we reached the end of this series, and we completed this series, but including all these the explanation. The samples will be available at the end of this video. You can find the link in the, and also you can download it from the GitHub. If you think this video was helpful, please support me with your like button. And if you have any questions, or if you have any idea about that, what would be the next, we can say that the sessions or the video, you can suggest me, and also you can tell me that which direction do you think we need to move. Definitely I will take into account and listen all these comments and prepare necessary we can say video about those topics. If you didn't subscribe to my channel, please do subscribe and help me to promote my channel. And thank you again, and see you next one.